So today what we're going to do is we're going to build something called an optical isolator on our PCB mount. And what it's going to do is it's going to allow us to send a signal from one of our Arduinos to another.
So what that means is we're going to have an Arduino that's running MATLAB right here. It's going to send a signal to turn on LED. And then it's going to be interpreted by this Arduino here, which is running the Arduino IDE. And we're going to do this all through a PCB in the middle. To start this project, we're going to be using a software called Autodesk Eagle, which has a free student version.
So when we open up Eagle, it's going to look like this. And this is very much a navigation page, which allows you to go and make either board layouts like we saw on the circuit board, or the schematic layouts, which is how the wires are connected within it. And it's going to package in something called projects, and I've got one down here which we're going to be utilizing and sort of developing today, which is for my optical isolator. So this green E right here is the beginning of my project, and inside that I have my schematic, which is just the layout that we have here. So these are 3 pins going to my Arduino, a resistor, a line right here for voltage reading, and then a photoresistor, so it's just a voltage divider with a photoresistor. And then on this side we just have an LED. We have the LED and a resistor, and then 2 more pins that are going to go out to a different Arduino. When I build this into my board, it's going to look like this. And I've tried to sit there and just map out where all the wires are going, so it makes it to where there's spacing, and it also makes it to where my components are close enough together to where they're going to be like easy to arrange. So to get started here, I'm going to click on New Project. It's got it down here now, and I'm just going to title this as my last name, which is fine. I'm then going to go in here, and I'm going to click on New again, and start with the schematic. So our first step is going to be to import our library. So I'm going to go up here, click Open Library Manager. I'm going to go over to Available. I'm going to click Browse. And I've downloaded a library file called Optical Isolator Library, and that's just the components that we need in this build. I'll select Open. We should see it populate in here. There it is right there. I do need to click Use. If I don't click Use, it doesn't go into the system, so I got to click Use. And now I can close out of this. Now I can go in and start adding my components. And so I'm going to go in, go down to my optical isolator. I'm going to bring in my 3-pin. And I'm just going to work left to right on the way that you saw that image earlier on. I'm going to place that right there, my 3-pin connector. Then I'm going to go in and add a resistor. Notice that it doesn't allow me to set the size of the resistor here because we're only worried about the PCB, which has those holes there. Then I'm going to go in and add my photoresistor. Right there. And since I have that there already, let's go ahead and start making connections. So I'm going to go right here to there, right there, to there, and come back around to there. My middle pin is going to be checking for my voltage divider there, and so I just need to connect right there, and the dot lets me know that there's a connection. We're now going to make the opposite side here. So now that schematic is done for what I want it to be able to accomplish. In other words, I want wires to go from my board to here to set up my voltage divider, and I want wires to come from my other Arduino to just light an LED up. Next thing we need to do is we need to develop a board file. And there's a button up here that just develops it for us. So it asks me if I want to create one from the schematic, which my answer is yes. When we go into the board file, it opens up this space, which is the board that I'm going to be working with. And then this down here is the components that I've inserted along with the connections that we've placed. And I just need to bring these over and space them correctly to make that happen. So I'm going to use my move command right here. I'm going to click on one of my items and drag and place it in place. When I right click here, it does allow me to rotate it, which is nice. I'm then going to use the move command again and drag that. Right there looks good. And my move command again to right there. I'm trying to make it to where I can see that the wires are not like crossing over each other, so I spun that resistor around because I had the wires coming from this side of that LED. And then you're going to do the next one. Now with things sort of oriented correctly, I do want to sort of drive everything to that bottom corner so I can be conservative with my board. And once I have like the setup where it looks like everything's compressed, what I'm going to do is I'm going to go up and grab the corner of my board, which I'm just doing that by scrolling my mouse wheel, and I'm just going to direct it to where it is nice and flat for me. And now that I've got all of my parts in the right spot, I've got my board shrunk down to where it needs to be, I'm going to add my traces, which are going to be my wires in this situation. And so to do that, I'm going to go over here, and I'm going to route a wire. And before I do it, I'm going to make this wire, let's go all the way up to 20. Right, and that's just talking about the thickness of the wire that we're adding. Right there. Cool. I'm now going to add a wire down here. I'm going to add a wire here. Add a wire to there. And we're kind of doing a little Ghostbusters here, which is just that we can't cross the strands. And so I'm trying to give myself some space as far as how that works. So that's looking good, but I do see that I have plenty of room to make these wires bigger. So I'm going to go in and just retrace them again with the 40 width. All right, and once I have that done, I'm in good shape to sort of save this file. So I'm going to go File, Save As, and I'm going to save it as my last name and then as the board file. Or click Save there. And once I've done that, I can take that over to my PCB mill and start milling it. Once my machine is ready and it's homed, I want to be able to utilize a single-sided PCB board. And I'm just going to use the tape which comes with it, which is Nito tape. I'm going to put one strip down here. One strip on the top. Nice. Screw down real good, pull the back side of the tape out, right? And then I'm just going to place that inside the machine. Press it down real well. Now what we need to do is we need to open up the Bantam Tools software. This isn't going to work without the machine actually connected to your computer. And so you may have to go to the lab or find one of these machines to work with it. I'm just going to check real quick. So I'm going to not worry about the tool right now. I'm going to check my fixturing in my bracket, which is there. I have a single-sided PCB in there, which is great. And I have home my machine. And so now I can go through and actually add a file that I'm working with. I'm going to click Open File. I'm going to navigate to my file, which is an Eagle Projects Klein. And I've just got Klein isolated here. And it's going to be the board file rather than the schematic. Open. I'm going to zoom in. Beware, it does allow you to sort of work with the placement. So the first thing I'm going to do is I'm going to go in, do my traces with my PCB engraver bit. And I'm going to have to insert that bit, and when I select change, it will walk me through a prompt of how to change that through. And I'm just placing the bit in the collet there. Once that's good, I can click Mill all that's visible. It's going to go around and cut these parts for me. Now with that done, I'm going to go through, deselect traces, select holes, and insert my 1/32 flat end mill and change my bit out to it. Our last step here is just going to do the outline, and I'm going to remove the holes with my 1/16 flat end mill, and I'm going to go through and change the tool out. Now that's done, we're going to click loading on the screen. And go in just using a standard screwdriver and pry out our part. And we've got. All right, so now that we have that, I'm going to go ahead and insert my parts. I'm going to set them through on the side that is not got the copper on it. I'm going to bend that over, and then we're just going to solder those parts into place. Once we're done soldering, we're just going to look on the back and make sure we're not bridging over any connections with the solder. So in other words, where we were milling, that is clean of the solder. And then we just have our part, and we can take that and implement that in our circuit. Good luck with it.